Hello everyone, welcome back to my channel. Today we are going to talk about route filtering and route manipulation, and I'm going to show you how you can perform route filtering with distribution lists and route maps, and also route manipulation, specifically metric manipulation with different routing protocols. It's going to be a simple scenario and simple lab scenario that we are going to have here. So as you can see on my screen, I have 4 routers here, and I have 2 routing domains, EIGRP Autonomous System 10 and OSPF Area 0 on the right side. So I have already pre-configured the routers, IP addresses, and routing protocols, and also I have already started the distribution just to save time. In order to get in line that what is going on exactly right now, I just want to show you. So if this is my scenario, what I am doing right now, I am redistributing from OSPF to EIGRP and from EIGRP to OSPF. This is right now our scenario. Let's jump into the routers. If I go to router 2, so let me put this in a way that you can see, right? Okay, so router 2, show IP interface brief. As you can see, I have gigabit 00, this interface 2222/30, and also this one 2424. So if I do show IP protocols, you will see that I am running already 2 routing protocols at the same time. The first one is EIGRP 10, which everything is default, and also OSPF process ID 1 that I am running. And here you can see that yeah, the router ID is 222. So if I do show run pipe section router, it's going to show me my exact configuration for both routing protocols. As you can see here, this is my configuration for EIGRP, and this is my configuration for OSPF. And you can see on the EIGRP, I'm already redistributing OSPF process ID 1 with these metrics, right? So if I jump into router 1 here, I'm talking about this router particularly, this router. If I go to router 1, I should see the routes. Let me do the routes which are redistributed to this routing domain, show IP route, and there you go. You have 3 subnets redistributed. You have 3 subnets which are EIGRP subnets, EIGRP routes, but with flag EX, which means there are external EIGRP routes. And the administrative distance is also 170, which is normal. So what are these routes? 10, 10, 10, 10. This is this one, LAN behind R4. And also these 2 point-to-point links between R4 and R2 and R4 and R3. That's normal. On the other hand, on router 4, if I come here and do show IP route, I am seeing right now, if I do show IP route OSPF particularly, I will see 3 routes receiving on OSPF, right? Which are external routes type 2, right? So it means if I do show IP OSPF database, I can see LSA type 5 here, and that's correct. The advertised router is the ASPR router. This is the ASPR router ID, and these are this particular link ID state of this LSA type 5 are the exact networks that are being advertised by ASPR into the routing domain, OSPF routing domain, right? And the very good question here is that why I don't see LSA type 4. Usually when you have LSA type 5, you should also see LSA type 4. It's an interesting scenario because right now my ASPR, which is R3, is it the same area with me? I'm looking at the LSDB link state database from R4 standpoint, right? Router 4 standpoint. And what I see from here, this is me, let's say. What I see from router 4, that router 3 is in my area, right? So, and this is the ASPR. So when I know how to get to the ASPR, by the information enclosed in LSA type 5, I don't need ASR LSA type 4 anymore, right? So if I had this is area 0, and if there was another area here, let's say area 1, and I had a router here like this, then this router, which is receiving, let's say I have a router, transit router here as well. This router here, which is receiving the LSA type 5 from this ABR router, then I would need to have a LSA type 4 propagated from area 0 to area 1 by this ABR router in order to in order to inform the routers in area 1 how to get to the ASPR, right? That's another topic that we will address it in other training videos, but I just wanted to show you that what we have exactly here, right? Okay, so let's take a look at R3 as well. I will make another, just a second, I will make another screen because this is too much messy here. Okay, so we are redistributing from OSPF to EAGRP and from EAGRP to OSPF. Let's take a look at R3 here. And look at that. I already entered show run pipe section router, and it's obvious that I am redistributing EIGRP autonomous system 10 subnets into my OSPF routing domain. Okay, so what are the objectives of our lab? So let's review the objectives. Objective 1, router 4 must see only 192.168.10.0/24. What's that? This is exactly this LAN behind R1. So objective 1 says from R4 point of view, right now what routes I am seeing, because it's been redistributed on R3, is this LAN IP, this LAN interface, right? This one, and this one, and this one. So what simply objective 1 is asking me to filter these two point-to-point subnets, and R4 only should see this subnet. That's pretty simple. We can do it in a couple of ways, to be honest, but for now we will just go with distribution list, and I will show you how you can do that with distribution list. So the first question is that where exactly I should perform my filtering. So the answer is pretty simple, that because router 3 is performing redistribution from EIGRP to OSPF, then I have to perform the filtering here, right? I have to filter, I have to educate router 3 to not send these two subnets into the OSPF area 1 routing domain. So let's do that. I will go to router 3, just a second. I will make it a little bit cleaner here, that we can see everything, almost. Oops. Okay. On router 3, I will go to configuration mode. Then I will go to router OSPF 1. Before that, sorry, I have to make my access list. So on distribution list, you have to, first of all, you have to identify the routes. You have two ways to do that. either by using access list or prefix list. In this case, we're going to use access list. So IP access list standard 1 permit 192 dot 168.10.0 and wildcard mask 000 Okay, as you know, this particular access list number 1 is going to take care of the job for me. Why? Because I will leave the implicit deny at the end of the access list, so I will not permit anything else. I will exit. Now router OSPF1 distribution list distribution list. Now it asks from me IP access list number or prefix or route map. So right now I will use just my access list number 1 and the direction out. So why out? Because I am going to filter outbound routes from this router. Any route is going outbound from this router, right? So you might say that, okay, let's do it on gigabit 01. Okay, let's do it. Gigabit 01. It's not gonna work. And it's gonna show me a nice error that interface not allowed with out for OSPF. And that's a very interesting topic. And that's very important note that you might see on your exam or production network, that on OSPF it doesn't let you to apply a distribution list outbound to an interface particularly. And why is that? The underlying reason for that is because if you were allowed to do that, you would mess up the link state database basic rules and laws, which says that in every single given OSPF area, the LSDB should be identical on all routers. So if you were able to filter some routes on this interface, it means that router 4 wouldn't receive the LSDB, the identical LSDB from R3 that is receiving from R2. And that's exactly bending the very first solid rule of OSPF. So a Cisco router is not going to allow you to do that. So what we can do is that I will type distribution list 1 out, and that's it. So that the command is taken. Now I will jump to router 4, and if you remember, when we did show IP route OSPF on router 4, we could see all the routes including our target route. Now I will do it again, show IP route OSPF, and there you go. You only can see 192.168.10.0 on router 4. So objective 1 is fulfilled. I will put it here, fulfilled. Okay, what objective 2 tells me? Oops, what happened? Okay, what objective 2 tells me? Router 1 must see everything but 24.24.24.0/30. That's interesting. So what it exactly says, that router, if you log into router 1, let's do that right now, router 1, and if I do show IP route EIGRP, I have 3 external EIGRP. The 2 point-to-point links from R4 to R2 and R3, and also the LAN behind R4, right? So objective 2 says that this router should see only this route, 24.24.24. The other 2 must be filtered. Okay, let's do that. Again, I will go to R2 this time. Why R2? Why not R3? Because as you remember, our distribution is like this, because I am distributing OSPF into EIGRP. So I have to apply the filter on R2 to not send the route advertisement to R1. Or Or other alternative is that on R1 I filter the incoming route from R2, and that would be useful if I had, let's say, let me do it again here. That would be useful if I had a switch here, let's say, and I had a couple of routers, right? And I wanted this router 1, I wanted to have the objective 2 to be fulfilled only on router 1, and router, let's say 10 and 11 would have been able to receive the routes. So in that case, I would apply the filter here on inbound interface. Now that I'm going to apply the filter here in outbound interface, it's going to affect all the routers which are in that LAN segment. But since we don't have any other router, so we can do that. So let's do that. R2, I will make an access list again, IP access list. Oh, I have to go configuration mode, IP access list, standard 1. Then I will say deny, this time, 24, 24, 24, 0, 0, 0, 0, 3. That's my wildcard mask. And then permit any. And why did I do that? Because the objective tells me router 1 must see all the routes, but must not see 24, 24, 24. So I'm denying it on my access list. So simply I will go again to just let me do show IP, show run pipe section router. Okay, I will go to router UAGRP 10, distribution list, distribution list, access list number 1, out, gigabit 0, 0, and it takes it. I am filtering on only this gigabit 0, 0. And that's interesting. As you remember, when we wanted to do it on OSPF, it didn't allow us, but on a ERGRP it does. And you can see that my neighbor relationship is resync. So it means that the EAGRP neighbor relationship went down and came back up. So let's go to R1 and see show IP route EIGRP. And there we go. I see the other two routes, 10, 10, 10 and 34, 34, 34.0, but I don't see 24, 24. So it means that my objective 2 is also fulfilled. Let's go to objective 3. Router 4 must see 192.168.10.0/24 subnet with metrics of 43. That's weird, but okay, this is what we are requested, what is requested from us. So let's do that. There are a couple of ways we can do it. I can make another route map on R3 outbound or R4 inbound and apply that. But if you remember on R3, if I go to if I do show run section OSPF, we already have a distribution list, right? So what if I remove this distribution list, and by making one single route map, I will show you how, I can fulfill both objective 1 and objective 3 together. Let's do that. So conf t router OSPF 1 no distribute this out. So if I go again to R4, I should see all the routes. Okay, they are allowed again. I will exit. I will make an access list, IP access. Actually, I have the access list, right? Show IP access list. Yes, I have the access list already. So let's make a route map. Conf t route map. We put it on route map 1, let's say 1. Permit, I pressed enter, so it means that by default it puts me the iOS will put me automatically on sequence number 10. Okay, so what we are going to match here, match IP address, which can be referred to access list number 1, right? Enter. Then set metric to 43. That's it. Exit. So let's do, before we apply it on our OSPF instance, let's do show route map. What we have a route map. It's called 1. Sequence 10 is permitting. Match clause, it's the if statement says that match, if you match access list 1, then set the metric to 43. And pay attention to the fact that I didn't make any other sequence on this particular route map, which means that by default any other by default the implicit deny on the other sequences of the route map is applied, and that's what I want. So I will go to my router OSPF ID1, process ID1, and I will just a second, do show run section OSPF. I just want to see my current configuration again. So I'm redistributing EIGRP. So I would tell him that redistribute EIGRP autonomous system 10 and apply route map 1 with subnets, all the subnets, right? Bang. So what we are going to see on R4, let's see if it works. Yes, look at that. I am receiving only 192.168.10.0/24 objective number 1. Everything else is filtered, and the metric is 43. So my route map here is working. If I do show route map, and you can see that this route map 1 I made is working on my OSPF instance. So that's it for now, guys. I hope this video was informative to you, and thank you for watching.